Hello, class. In this video, we continue with activity 5.1, our treatment on rational functions. So let's take stock of what we've done so far. For any rational function, we are able to determine the domain, the vertical intercept, the horizontal intercept, the vertical asymptote, and now we're going to discuss the method of finding horizontal asymptotes. There's actually two ways we can do this, so I will go through the various methods over the course of one or two videos. So let's go back to our book. And if we look at page 404, you'll see a graph of the function y equals 2x plus 12 over x minus 4. And you remember when we actually graphed this function, we talked about that imaginary dotted line that occurred at x equals 4, because x equals 4 would give us a 0 in our denominator. But there was also another imaginary dotted line, right? So we had a vertical imaginary dotted line at x equals 4, but if you can see from this graph, there's another imaginary dotted line that our graph never touches. That's going to be our horizontal asymptote. So the question is, how do we determine the equation of this horizontal asymptote? We have two methods. So we'll start with the method that the book chooses to use. First, let's actually graph this function in our calculator. So I'll take out my TI-84, and if you press y equals, you enter the function. Make sure you isolate the numerator and denominator by using parentheses. And again, the function that we're graphing is this one down here. I changed my window. I went from -10 to 10 and -15 to 15. I press graph, and there's my function. And again, my calculator does not draw these imaginary dotted lines, but we know they're there. So what the book says is really what happens when x gets really negative, right? If you look at the hand on your screen, I'm tracing the graph. As I make the graph really negative, this line is going to get very close to a number but not touch that number. And we want to determine what that number is. And if I go make x really large, right, my hand is tracing this graph and going to the right. As x gets really large, what happens to y? Right, we're going to approach a number, but we're never going to touch a number. So really, that's what we're trying to do. We're trying to determine the value of y when x gets really small. When x becomes really small, what happens to y? And when x becomes really large, what happens to y? So the easiest way to do that is we can go to our window and actually our table, and we can set up our table to count by. They use 1,000. I'm going to use a smaller number. I'm going to say maybe 500. So if I press second and then the window key, because above window it says table set, I'm going to start at 0, but instead of delta table equals 1, I'm going to change that to 500. That just means we're going to count by increments of 500. Now when I press second and the graph key, you see x is 0, 500, 1,000, 1,500, right? So as x gets bigger and bigger, what happens to y? You see here y is 2.04, then 2.02, 2.01, 2.005. You can see y is getting smaller and smaller, but it doesn't look like y is going to go below 2, right? Y is getting closer and closer to 2, but never actually touches 2. Right, and that kind of makes sense, right? When you think about your graph, when we think about our graph, originally y is a big number and then gets smaller and smaller, right? Y is getting smaller and smaller as I go to the right, and eventually it's getting closer and closer to 2, which happens to be the equation of this imaginary dotted line, but never touches 2, right? So I'm above 2 as I go to the right, but I never actually touch 2. So I go back to my graph. What happens if I make x really small, right? If I were to go the other direction, I keep pressing the up arrow. If I make x really, really small, meaning very negative, right? We're at 7,000, 6,000, and so on. What happens if I go negative? Now you're going to see I'm going to be below 2, and eventually my graph's going to approach 2. Okay, so you see as x is negative 500, I'm at 1.96, 1.98, 1.98, 1.99, and you can see I'm below the number 2, but I'm getting closer and closer to 2 as x becomes more negative. So as I move to the left on my graph, I'm below 2, right? I'm below y equals 2, and I'm getting closer and closer to y equals 2, but I never actually touch 2. So that means we can assume that there's an imaginary dotted line that we never touch, and the equation of this imaginary dotted line is y equals 2. So we have a horizontal asymptote at y equals 2, and we have a vertical asymptote at x equals 4, right? So the vertical asymptote goes through the point, the value of x equals 4, right? 0, 4, or 4, 0. All right, so the equation of this vertical asymptote is x equals 4, and the equation of this horizontal asymptote is y equals 2. Again, why is it y equals 2? Well, that's the number that we get very close to, but never touch as we make x very large, and as we also make x very small. In the next video, I'm going to show another way to find the horizontal asymptote that many of my students have said is an easier way to determine the equation of the horizontal asymptote. So look for that video shortly.